Okay, so welcome everyone. This is the Quant University Summer School session, and this is the final session of the summer. I hope you had a wonderful summer. I hope you got a chance to take some time off with all the, I think this is like the final holiday before the real holiday season starts in November and December. I know Christian and Tommy who are joining us and who are at IBM, but also key contributors for the Mlx project have been extremely busy. So I'm very much appreciative of they taking their time off their busy schedules and joining us for the summer school session. And as you all know, we've been having the summer school sessions throughout the summer, and every Tuesday at 12 o'clock, we have an invited speaker who has been working in the area of machine learning, data science, primarily focused on productionizing machine learning systems. And we have also had various themes in the context of explainability, looking at machine learning monitoring, looking at ways in which you could focus on model governance, and looking at model risk management from various perspectives. So we've had a variety of different speakers from the academic community, from the practitioner community. And as you all know, Quant University recently joined the LFAI Foundation, which is incubating various open source projects. And there have been some amazing products and projects which have come out of this effort. And through that effort, I got to know about the Mlx project, and I was very much interested in this whole notion of cataloging of machine learning models and data assets. And we thought we'll invite the contributors to the Mlx team and have them present what the focus is about and how they're envisioning this project kind of expand, and also see if there are opportunities where in the community could contribute. So before we start that, I just want to acknowledge all the participants of the summer school. I know people from various countries have been joining these summer school sessions over the last 13 weeks or so. We have had courses we have offered formally focusing on data science, machine learning, stress testing and scenario testing, algorithmic auditing, and model risk management. In addition to that, we have had multiple guest speakers who have taken their time and presented during the sessions. We have had sessions from NVIDIA, from New York University, Wells Fargo, University of Cambridge, H2O, Regents Bank, Warsaw University, and today we have Christian Kadner and Tommy Lee from IBM who are going to be talking about the Mlx project. Give me 1 second. So I think it's the 48th session. So today we are going to be talking about the Mlx project, and Christian is a software developer at IBM focusing on open source projects. And I don't know what KFP Tecton stands for, Christian. You may want to even talk about that. But he's been focusing on various projects in the machine learning ecosystem. And Tommy Lee is a software developer at IBM focusing on cloud, Kubernetes, and machine learning. He's one of the contributors of the Kubeflow project, and also you should probably tell a little more about the Kubeflow pipeline aspects, which I think Animesh was kind of posting some aspects on the channel. So I welcome you both to the session, and the protocol, as you know, we have 45 minutes for presentation. And for people who are listening in, please type in your questions in the Q&A panel. And if it's very contextual, I will interrupt Christian and Tommy and bring up the question. Otherwise, we'll reserve the last 10 to 15 minutes or so for Q&A. So thank you so much again, Christian and Tommy. Welcome, and please take it away.
Thank you, Sri. I'm going to try to share my screen again. Okay. Okay. On my screen, it shows the first slide of my slide deck.
Yes, we can see that. Yes.
Okay, fantastic. All right. Hello, everybody. My name is Christian Kadner. I work for IBM, as well as Tommy. We work for the IBM Center for Open Source Data and AI. And we're a group of data scientists and open source developers, mainly headquartered in the San Francisco Bay Area. And we focus on making, open source AI models easier to create, deploy, and manage. And most of the projects that we're working on, they are focused around AI. Projects like AI 360, Trusted AI. We have projects that center around data sets, data models, and currently Tommy and I are working on the machine learning exchange project, which we are going to present in this presentation. Shri already introduced us, so I'm going to skip that. Going to go back a slide just to show our agenda or what we're planning to do today. After our presentation, we do a quick demo, if the demo gods allow us to do it, and we'll have a quick workshop at the end. And since everything that we do in machine learning is very resource intense, we rely on Kubernetes, we set up clusters, and that's not something that we can do quickly in a workshop. What we can do, however, is use Docker Compose. So we have a small, very compact deployment of the machine learning exchange that can run on a standard laptop with Docker Compose. So for any of you who want to follow along at the end of our little workshop, if you don't have Docker Desktop or Docker Compose installed, maybe you can kick off that install while I'm running through the presentation. It shouldn't take too long, like it might be a couple of minutes, and you can leave it run in the background. And then by the time we're ready, hopefully it will be working. If you don't want to do it, that's fine too. You can just follow along on the screen as we go through it. All right, let's start with the presentation. So what are we talking about today? The machine learning process is, a very, very involved process, right? There's many steps to it, many things that have to be done. And in order to get any kind of value out of your, machine learning models, you have to do a lot of preparation before it gets deployed and, does anything meaningful. And usually for data scientists, that starts by, gathering the data, analyzing it. Often, lots of pre-processing steps are involved. Then you have to build your models, machine learning or deep learning models. There's all kinds of algorithms and frameworks involved. And then once you have your model, readily trained and retrained, you have to deploy it somewhere. You have to make sure it's scalable, so that you can scale up and down depending on the workload. And you also have to maintain it. If data changes or regulation changes, GDPR, one example, you have to go back and retrain that, check it for bias. And all of that is to say that, machine learning doesn't come cheap. It's not easy, and usually involves not just multiple steps, but also multiple people. I'm trying to go to the next slide. Okay. It was just slow. And that's where pipelines come in. So pipelines help with the management of that process that involves so many steps. Oftentimes, because this work is done by teams, not just one data scientist, but many, all these individual steps have to be, put together and managed, and, you have to be able to make changes in individual steps and then rerun the whole process without, too much of a hassle. So typically in your pipeline, pipeline is an organizational construct as well as an execution construct. So all of your data preparation steps, data cleansing, ingestion and analysis, transformation, your validation and your data splitting, then leads to the model creation. You're building your model, you train it. It has to be optimized, you validate it. And then once your model is ready, you roll it out. The deployment, that can happen, on an edge device or in the cloud. And, of course, once you have your model deployed and you serve it, you have to, do some inferencing, right? So data coming in, you have to make sure that that model is deployed somewhere where it can consume or where it, can tolerate the workflows that, that your application demands. And while that's happening, you have to, of course, be able to monitor how your models are doing. You have to monitor the workload. You might have to optimize it and fine tune it. And that whole life cycle, depends on maintainability, transparency, and speed. And oftentimes these processes, they're not just complex, but they also get repeatedly implemented by various teams. So there's a lot of duplication that's happening, especially in the assets that are being created, the data sets and the models, the pipelines. Oftentimes, even within an organization or within a company, there are several teams of data scientists who repeat, most often the same kind of work steps. And then, of course, when there's additional challenges of traceability and governance, you have to manage your risk. You have to be able to track the lineage and your metadata. There's a strong need for a tool or a way or a framework to help with all of these individual steps. So having one need being taken care of, which is the sharing of these assets, that's a crucial part to speed up that development and that AI lifecycle. And oftentimes those assets that can be shared, are your data sets, your models, and the pipelines that, structure your machine learning workflow. And such a catalog ideally should be able to be shared, across organizational boundaries, and, not just being shared, but also being maintained by, individual data scientists who can upload data sets and models. And these data sets, models, and pipelines, they should be versioned, and you should be able to see what was changed and when. And so that, having ready-made data sets, models, with high quality checks and proper license lineage tracking, it can hugely increase the speed and the efficiency of your AI lifecycle. And that's where the machine learning exchange comes in. So the machine learning exchange that is an open source project that is fairly young. We released it a couple months ago. And as I mentioned to Shri earlier, we haven't formally announced it yet. It will be announced at the end of the month on the Open Source Summit, which is hosted by the Linux Foundation. Now, in Mlx, we have two main parts. One part is the catalog for sharing all of those individual assets, our pipelines, data sets, notebooks, models, and pipeline components. And then we have an execution engine underlying it all. So if you deploy it on a Kubernetes cluster, it will be running with Kubeflow pipelines. And Kubeflow pipelines is powered by Tekton in our case. But even without the underlying execution and orchestration engine, you can still use the catalog. So that's what I'm going to show in our little demo or in our workshop at the end. Here's a little architectural overview. So the Mlx has a UI and an API server. There's an SDK that you can use to interact with the API. It's a Python SDK. And our data is stored on the cluster in a relational database. We use MySQL for that. And we also have an S3 object storage. We're using MinIO for that. And we get those two, or we get much of our backend via means of Kubeflow pipelines. So the relational database and the object store that basically come ready-made for us, and we only add the API and the UI on top of that. And then some of the technologies that Tommy will explain later that we are leveraging are DataShim to manage our data sets, to deploy them on the cluster, KF serving to serve our models, to run our notebooks. We use a sister project also developed by the IBM Center for Open Source Data and AI called Lyra. And many of our assets, our models and data sets, they are provided by another open source project also from the Center for Open Source Data and AI called Max and Dex, the Model Asset Exchange and the Data Asset Exchange. Let me quickly see if I missed anything here. Oh, and yeah, another integration we have is the model metadata. Our schemas are aligned with ML spec. So let me, so we have a few animated GIFs here that run at their own speed. What you see here is our pipelines view. So each individual pipeline, has a YAML file. In the world of Kubeflow pipelines, or in Kubernetes in general, most of the metadata, all of it is either JSON or YAML. So a pipeline is represented by a YAML file. And here you can see how we can launch our pipelines. And then you see the screen that you might be familiar with from Kubeflow pipelines. It shows the individual pipeline step, the graph format. And then for each of the pipeline steps, you have details. You can see what were the inputs, the outputs, and you can follow along with the logs. And you can inspect or get some details about the pods that were created on your Kubernetes cluster. Similar for components. Components are individual pieces of a pipeline. So a multi-step pipeline, heavily relies on well-packaged individual steps, repeatable steps. And Kubeflow pipelines gives or provides a concept called components. And each of those components, as you can see here, can be, created or written with a, as a Python DSL script, and then compiled into, a small pipeline. In Mlx, we have the capability to generate sample pipeline code, Python DSL code for all of your individual assets. And then your individual components, when they're wrapped in a simple pipeline, you can run them and you can see what the component does. This is useful because oftentimes these complex pipelines, they break down into various steps, can be very complicated, graph arrangements, and making sure that your individual components can run, as their own units with all the inputs and outputs might be useful. So when a data scientist wants to share a new component, they can upload it here. They can see the sample pipeline code that's generated. If that is not what they want, they can upload their own code and then run it in the pipeline. And once it's ready, they can share it and publish it so that other team members can use those components and add it to their pipelines. Our models and data sets, as I mentioned earlier, they are from a sister project, the Model Asset Exchange. That's why all of our featured models here start with the MAX Model Asset Exchange. And what that project has done very well is create a well-curated collection of models and data sets for us. And, for each of those models have provided the metadata, gathered all the, the pertinent related information, where it's stored on Amazon, have, created great READMEs and documentation about it. And we are trying to integrate that in the machine learning exchange project. And of course, for your models, you can also launch them and a try run. When you want to serve them, you have different options for what kind of platform you want to serve them on. KF Server being one of them, or natively with Kubernetes. And Tommy will show it. This is a view of our data sets. For all of our assets, we try to provide 6 or 8, 10 default assets, so that when data scientists, if they wanted to pick up machine learning exchange, they have something to work with already, to see it as an example or to even use it in their workflows. And this particular data set here is the NOAA weather data, which we'll use later in a demo for our JFK Airport notebook. And last but not least, we have notebooks. Notebooks are important because that's one of the main vehicles that data scientists use to go about machine learning, right? To do many of the steps that are required to prepare the data. And usually, notebooks are run with Python, and then various machine learning frameworks can be leveraged in Python and visualizations. And as you can see here, we have a notebook viewer. The Python notebook can be, rendered. And when a pipeline is being, or a notebook is being run, that notebook can be regenerated and, can then be visible to other data scientists that, that are looking at the same machine learning exchange deployment. And of course, all those notebooks, they can be run as part of a pipeline. And for running those notebooks, we use, as I mentioned earlier, the Elira project. And I think Elira internally uses the PaperMill library to run the notebook with input and output parameters on the cluster. Once such a notebook has been run as a pipeline, the output of that will be all of the artifacts that get generated, as well as the notebook itself that gets re-rendered and then stored in MinIO, and then data scientists can look at the finished notebook. And now we're coming to the technologies we have integrated in Mlx, and Tommy will be speaking to those slides. Tommy, when you're ready, I can.
Yeah, you could go to the next slide.
Advance.
Thanks, and thanks, Christian. So for machine learning exchange, we are leveraging like few core technologies to help us like scale and run more machine learning workload more efficiently. One of the core technology we integrate is with Kubernetes. So Kubernetes is an open source container orchestration platforms. And they have very powerful tools. In terms of like UI interface, you have like very nice graphic UIs and CLI to interact with the Kubernetes cluster. And with a Kubernetes cluster, there's a concept of master node and worker node, where master node is all the microservices that help you manage. So I think, Christian, your screen is off. Yes, thanks. So in the master node, all the microservices for managing the lifecycle of all the other containerized applications. And where the worker node is where the actual containerized application from the user actually executed on. So as you can see, when the master node, you have API servers that handle all the API requests, scheduler to schedule all the job executions. And then you have a controller manager to manage all the lifecycle other container parts. And XCD is for managing the job history of all the containerized applications. And then within the worker node, you will have the containerized container execution platform. In this case, you use the Docker desktop version. Then you could use the Docker containerized runtime. And you use other cloud provider, they might usually use Containerd as the container runtime in this case. And then behind the scene, you will have Kubelet to manage the communication between the master node worker node and the kubectl for the networking aspect. Christian, can you go to the next slide? And with this, we also integrate what we call a data stream. Data stream is open source project for creating data sets custom resources for hosting all the data set on Kubernetes cluster. A concept in data stream is what we call data set operator, where we define our own controller to manage the lifecycle of a data set. So in this case, when we create a data set, let's say pointing to S3 host buckets, behind the scene, this operator will help us create in Kubernetes what we call persistent volume claim. It's a shareable volume across the whole Kubernetes cluster. So user could just use that volume when they execute any machine learning workflow and simplify their lifecycle when they run any machine learning workflow on Kubernetes. Next slide. And then for models, we're integrating with an open source project called KF Serving. So KF Serving is a project for serving machine learning models on Kubernetes and leveraging some of the core technology like Knative and Istio to do canary deployments, serverless application for models. So we could save and scale models very easily. And within KF Serving, there's some like core concept to help data science to do like pre-processing and pro-processing for their models. And as well as explanation, where it helps the model to explain whether or not it's fair, it has bias or not, and does it have any like outliner. So we will have to like retrain the models and make sure like it compromise with all the governance requirement from our data science aspect. Next slide. And then last and not least, all our execution on machine learning exchange are leveraging what we call Kubeflow pipelines. And this is the pipeline that is based on Tecton engines. And how Kubeflow pipeline was done traditionally is usually user will interact using a Kubeflow pipeline SDK. It's written in Python. And once they have the SDK, they will compile into a Kubernetes understandable YAMLs and send it to the API server from Kubeflow pipelines. And in Kubeflow pipeline, there will be a relational DB that keep track of all the job history and object storage to keep track of the metadata. And user also could use the Kubeflow pipeline UI to interact with the uploader pipeline as well. And behind the scene, when the pipeline is executed, the pipeline, the Tecton engine is actually handled the pipeline executions, where it create like one container for each task. And when each task, you might have multiple steps, and each step inside the task is corresponding to a container. So you could actually have a very complex workflow using like the Kubeflow pipeline definition. And in machine learning exchange, you could do the same thing as well. And we're also leveraging one of our core technologies to have you auto-generate some of the commonly used pipelines, so users can have a more like easier experience without even using like the Python SDK in this case. Next slide. And last but not least, with the recent announcement with the Watson machine, with the Watson Studio pipeline open beta release, we're also able to allow users to create repeatable and scheduled workflow that automate like notebook, data refinery, and machine learning pipelines inside our Watson Studio products. And this is built on top of the open source project we have just talked about, the Kubeflow pipeline on Tecton runtime. And it's also like fully integrated with all the services on Watson Studio platforms. So user can able to like just use this drag and drop UI to easily like combine their notebooks, data refinery flow, auto-AI experiments, any of the web services and online deployment for their models, and doing batch deployment, import and export of project jobs, all on like this single UI drag and drop, as you can see. And this is very powerful. 2 weeks ago, and anyone that have access to a free IBM Cloud account could also try it out as well. So I'm welcome anyone to like go try out on Watson Studio if you have time. And next slide. So I think that concludes the integrated technology we have used in machine learning exchange. So we'll give back to Christian to start our first demo.
Yeah, thank you, Tommy. I'm hoping everything is working. So right now we should see my web browser. Tommy, can you confirm the machine learning exchange?
Yes.
Okay, fantastic.
Yes, we can see it.
Awesome, thank you. So this is a deployment of the machine learning exchange on an IBM Cloud Kubernetes cluster. And when we set it up, we pre-populate data sets, models, and pipelines with our default catalog. With our default catalog. We make it a bit bigger. And one demo, or we plan 2 demos for today. A quick demo here would be will be me showing this NOAA weather data set and deploying that data set on our cluster, meaning that we will generate a PVC. So the data set will be downloaded onto the cluster and cached and available for other pipelines to use that data set. This is just showing that each data set has a description. The description of a data set shows what are all of those, what are the metadata, like the license, what's the domain, what's the size of the data set, where is it, where can you find out more about it, what's the origin of it, what are the files involved, the format of those files, and how to use it. And at the end, usually there's a bunch of links where you can find out more, or where you can, see, a demo of the data set, or maybe find a notebook that uses that data set. All of the assets that we manage in the machine learning exchange, they have some YAML metadata. And so when a data scientist, wants to contribute a data set, they can go to our GitHub repository, which I will show in a minute, find out what the required YAML structure is, depending on the asset type, and then, upload the data set. This is just some, YAML that I'm gonna skip over. Here, I'm gonna be able to launch a pipeline for that data set, and that pipeline does two things. It will generate some metadata that we need in order to create a PVC on the cluster using DataShem. So I'm gonna just run this one in the Kubeflow namespace. And once I click submit, I should see the Kubeflow pipelines run overview. That was already shown in the in our animated GIFs earlier. So now here you can see this is a two-step pipeline. The second step didn't show up yet. You will see run output later. You can verify, what the configuration is here if something goes wrong. Now you see the second step for that pipeline came in. We had generated our metadata, and now a persistent volume is being created, and that's been done by DataShem. And if you are getting impatient, you can follow along in the log output view. And so this one says that this data set has already been created because I ran this pipeline earlier, and now this PVC is mounted on the cluster. Now, now that we have this data set, we can go back here, and we can see that there are some related assets. Now, related assets are other assets within Mlx. So here there is a notebook called the JFK Airport Analysis, and that notebook makes use of this data set. So now I can run that notebook with that already mounted data set. So here I would have to plug in the ID of my data set, PVC. The data set PVC ID or name is usually derived from the asset ID, and then it's to be mounted somewhere. So I'm going to put that on temp data and launch that. Oh, I need a run name. It worked without a run name. And now this notebook is running. We created a new experiment. Experiment is a Kubeflow pipeline concept. And experiments group individual pipeline runs. In this case, this is one of our notebook runs. And while this is running, again, you can follow along with the logs. Usually when anything starts running in on a Kubernetes cluster, a pod will be created, and usually a pod, or pods have one or multiple container images, and these container images usually have to be pulled from Docker or other places, and that usually takes a while. So this notebook run may be delayed by a little bit. So I'm going to go to my previous notebook runs, and I can find an earlier one and just show that for the sake of time. So this one has completed successfully. You can see it was mounted, the data set was mounted here, and these logs are already too old. So I'm going to go back to the run I just kicked off, and I'm hopeful that the logs will starting to stream, but they don't. So for some reason, the cluster is slow today. Tommy, I'm not sure if there's anything I can do to make this go more speedy now. So what we would see here is a bunch of logs. And at the end of the logs, there would be a link to the notebook that got regenerated. And then if a data scientist wanted to see that newly generated notebook and download it, you can either go to the data set and download it on the download button here. And then the download is a TGC file. I can save that locally and then unzip that. And in that unzipped download file. We should be able to find the individual notebook file, the YAML file, and I think the generated pipeline script. Trying to get the screen to be shrunk. Trying to find that file. My computer is being very slow, I apologize. Under downloads, modified. And I apologize, my notebook is not part of the download, so that's definitely I need to fix, something I need to fix. So what I was expecting here, and one thing that I will do after this demo, is make sure that the generated notebook from that notebook run, which will look like this, will be part of the download. And then if that notebook regenerates, would regenerate some output like a graphic, bar charts, all these numbers, you would see those regenerated from the pipeline run. Tommy, with the cluster being slow, I'm hoping that you will have more luck with your part of the demo. I'm going to hand the screen over to you.
No problem. Let me showcase the demo for.
Can I ask a question about this particular demo, Christian?
Oh, yeah.
So what's the main goal of this? It looks like there is a YAML structure. You're trying to basically advocate to kind of build out the metadata for this data, right?
Yes.
So is this YAML structure a standardized one? Is that something which is going to evolve over time? How will you manage versions of it? How will provenance work? And it looks like the developer is going to be mostly doing the cataloging. So how do you envision this kind of fitting into the big picture of kind of standardization of data sets?
That's very good. So as I mentioned earlier, we use ML spec for some of our metadata. So we do have disparate assets, right? So you've seen we have data sets. The YAMLs for those data sets, we designed that. And so we did, well, by we, I mean, we have our data sets come in from the dataset asset exchange. Our models come from the model asset exchange. So they determine much of the metadata. And then we added things that we needed in Mlx to make sure our catalog works and we can run those assets. For pipelines, for example, the pipeline YAML that we have here, that is a Tekton YAML. If we were using Kubeflow pipelines with Argo, it would be Argo YAML. So that's where that YAML comes from. For components, that is a Kubeflow pipeline determined format. So Kubeflow pipelines, they have that component concept. They spec what should be in that YAML, and we're using it that way. And for notebooks, I think we came up with our own metadata that we needed to make sure things run. And then there's a source link here that points to GitHub. So that might evolve. Most of the things that we work with evolve over time. For pipelines with Tekton, the more stable the underlying projects are, the more stable the YAML is expected to be. So Kubeflow pipelines components didn't change a whole lot in the last 6 months. The pipelines YAML didn't change a whole lot. I mean, whenever there's a new feature, you will see that the pipeline also changes, but the things that we pull out of those YAML structures often doesn't, right? So we need a name, a description, some metadata, how it can be run, and related links, so that we didn't have many changes that were impacting us. Now, if you want to see what the YAML metadata should look like, I wanted to show that later. You can go to our GitHub repository. And so let me do that right now. Oh, that is not the right screen. But it doesn't matter. So under the machine learning exchange, Mlx, you can see the Mlx repository. This is for the runtime. And we also have the catalog repository, which has all of the the asset metadata. And there, if you want to find one of those assets, you can see the metadata for a particular asset, or you can see the metadata definition, which means what is required in that YAML, why is it, or is it required or not? Many of those fields are optional, and what it is for, to give the users guidance for what to put into the YAML files. Does that answer your question, Sri?
Yeah, and also is this if a company wants to change the YAML structure, I presume it's going to change the schema of the backend. So what flexibility do they have to add or modify fields in their YAML structure?
Okay, that is true. So the YAML files, when there is a change in the API that requires a change to these YAML files, then yes, there's a dependency there. If the YAML file information is not something that is required by Mlx for either execution or presentation, that YAML file can be changed. There can be new things added, things that are optional can be removed. So we really rely on very few pieces, like the ID, the name, description, the license, mainly for display, and then for models, for example, if we can serve it or train it, and what platform we can serve or train it on. So depending on what those changes are, if they are not related to what Mlx can do or what Q4 pipelines, or what is needed to run them with Q4 pipelines, then anything can be added or changed to the data.
Okay, and is there a notion of tracking wherein you kind of track like what has happened with one schema to another versus if the data changes or if the data schema changes over time?
Yeah, so Q4 pipelines, we're using Q4 pipelines under the covers here, and the pipelines themselves, they are versioned. So if a new version of a pipeline is uploaded, that comes with a date and a change, timestamp, of course, and we have that for our other assets as well. It's just in the UI, it's not yet supported, but yes. So version tracking will be part of this.
Okay. And who do you envision as the primary user of this platform?
Yeah, that's a good question. So our idea is to make it easier for data scientists to share assets in teams, right? So we can imagine that Mlx gets deployed, on an on-premise kind of cluster that is only accessible by one or a few teams of data scientists. But a larger organization could also deploy Mlx just for assets that are curated to be shared among an entire organization. We also have a read-only deployment on the mlexchange.org. And so that's basically just a showcase for now. But since if there's no data being shared here that is sensitive, that has any PII or other license restrictions, that could be shared with the wider public as well. So there's different deployment models that could be envisioned here.
And the data, I may have missed this. Is there, you're basically capturing the metadata in here, but the data resides somewhere else, or?
Yeah, that's right. So the Mlx, so until like for the data sets, I wanted to show that the data gets downloaded and mounted in a PVC. That's where we get the data, and we get the data from wherever it is stored. That storage is somewhere in the Amazon, for example, as an S3 file, or it could be anywhere. And usually our data sets, I'm trying to look for it here in the YAML ideally, there will be a link to where that data set resides, for example, or where the model resides. For example, here you see the repository, and then there you would find that tar file. So Mlx itself doesn't come with any models or data sets. The data is not being part of. So
but it does provide, or is it generic, wherein you say, okay, here is the Google storage, or here's S3, and you basically point it to storage. It's kind of it doesn't kind of provide any kind of a deep copy which is indexed and ready to go from a querying perspective directly through the interface or through the platform. It's more of a metadata, which is kind of telling you where data assets reside.
Yes, exactly.
Okay, and the same thing with models and pipelines too. It's mostly, kind of doing the ledgering or the bookkeeping of where the various assets are.
Yes. Well, with pipelines, it's a little different because the pipeline is basically just a YAML file. And then once you run the pipeline, the individual steps, they will pull that data if they need to pull data, or, it has been mounted in a PBC if data sets are involved.
Okay. And for some of the, I'm sorry, I'm asking a lot of questions.
That's good.
I mean, at the cost of, not kind of going breadth, I want to kind of just understand like the key pieces, because many of these themes we have kind of discussed in the last many sessions through the summer school. Now, with respect to the data sets, if the data changes, the metadata also needs to be manually changed. There is no alerting or kind of, something changed. Or if, for example, if I'm kind of using an open source data set and the open source data set is changed, there isn't any kind of intelligent, okay, hey, you're using 1.3 version of this data set, but by the way, 1.4 has been released, so you got to update, or there is a new metadata. So the metadata doesn't automatically kind of change. You have to marshal the resources to kind of bring in the changes to your system. Currently,
yes, but that's a good requirement tree. So having like something that runs daily, right? Like a cron job that goes and looks for updates to version or to new later versions of those individual assets. That could be, something we can work on. And then
feature request. You got some
feature request, exactly. But you raised a very good point. That is true. Yeah, currently that's all manual.
Okay, cool. Thank you. Yeah, sorry, Tommy, I held you up for the next part of the demo. Sorry.
Hey, no problem. So demonstrate how we leverage self technology when we host our models. So let me start sharing my screen. The notebook asset. So in this case, I'm going to show you the model asset in here. You probably could see like we have a list of pre-uploaded models, and in each models you could see a description on what this model is going to do, and also like a YAML definition on where is this model located. For example, and for this model is actually already predefined as a Docker image, so yeah, ready to be served at any time. So because we could serve this model at any time, so we could actually from Machine Learning Exchange, we will have a launch section where you could actually choose whether or not to serve a models or training. In this case, it's only provide the information for serving, so we would just go for serving. And there's two platforms we could run for serving. One is Kubernetes, pure Kubernetes plain deployment on just regular pods, or you could use scale serving where you have more complex capabilities to do like Kadner deployments and traffic drift as well. So in this case, for some simplicity, we're just going to do like the Kubernetes deployments. And for the run name, we could just use the default max image caption generator. So just a small description of this model. So this model is going to take an image as input and return like captions on what this image is about, just using the machine learning models. So let me go ahead and start to deploy these models. And once we click deploys, behind the scene, we use a default pipeline to help us actually pull information from the web to see, okay, where is this model located? And we will just create this model image and run it on Kubernetes cluster. So from here, you could see the traditional, it gets the model configuration and then predefine them. And then once this step is ready, then it will create a next step to actually run the models on this Kubernetes cluster so we can actually use them. So I think once this is ready, then we will have next steps to deploy the models. And once it's created, then we have the model reside on our Kubernetes cluster's IP and the node ports. So we could directly just click on this link. So this is already running on our cluster. And with this model, it actually comes with a Swagger UI, so it's easy to like test it out. And you could see like there's some set of basic metadata, you could check out with these models. So you could see how to use this data and how to use this model URL, and then how there's all the metadata on the name of the models, what this model is about, and what type of model. This is an image to text translation model. And then to try out how to use these models, we could use the post request the model predicts. And because the input of this model is an image, so we are just going to use one of the image I have. I could use, let's say, my profile image, and execute. And they will return a list of results on the caption that's generated based on my uploaded image. So the model just thinks the image I upload is a young man wearing a tie and glasses. So which in my image is just wearing glasses but no tie, so it's not that accurate. So you can see the models probably have some improvement needs to be done. And this is how you could like test out the model, and then how you could use the model for other application is all like written in this Swagger UI. You could use this curl and reformat it to your application to use as well. So that is the summary of how to run the models on Machine Learning Exchange and how to apply on your application. Is there any question at this point? If there's no questions, we could go ahead and start the workshop sessions. Just go ahead, go over like what we could do with the workshop, and at the end we will answer like Q&As to cover any other question in the chat.
Tommy, do you want me to share my screen again?
Yes.
Okay. So it's our catalog. So for our workshop, I'm hoping that most of you or many of you are going to be able to follow along. You have, oh, that is not the Mlx I was looking for. So whenever you create a project with a name, you've got to make sure that your name is yours and no apartment listing comes up and people look for you. So in the Machine Learning Exchange project here on GitHub, you can find us, you know, if you either type in the Machine Learning Exchange in Google, one of the first links on GitHub should be our project, or you can spell it out, machine-learning-exchange. And in our GitHub organization, we have two main repos. That's the Mlx for the runtime and the catalog for the individual assets. And if you get a chance to try it out and like what you've seen, please give us a star. And so in that repository, you will find the typical GitHub structure. You have a README that describes the project, gives a little architectural overview. There are links that guide you to the documentation you need to deploy it. You can deploy it on OpenShift or on just any Kubernetes cluster. It shows you how to, once it's deployed, how to access the UI, and gives you a link to how to upload a new catalog or individual assets, troubleshooting, links. If you want to get involved, you can find us on the Linux Foundation under mlxchange.org. I'll have a link at the end of our presentation for that as well. And for a quick start, we created a quick start guide that works with Docker Compose. So under mlx/quickstart, you will find a README that describes what needs to be done. You would start by cloning this repository onto your local, onto your laptop or your computer. Given that you have, enough resources, and the resources required here would be 2 to 4 gigabytes of RAM and approximately 10 gigabytes of free storage. Although I'm not quite sure how much of that we actually use. Probably that's a Docker Compose requirement or Docker requirement for all the images that will be pulled. Now, once you have cloned the repository, you would do, a git pull to update the code. If you just cloned it, you don't have to do that. And then Docker Compose pull will make sure all the images get pulled onto your local hard drive. And once the images have been pulled, you can bring up the application. And then once all of the individual images have been pulled and the containers have been started, there should be an output that looks similar to this that tells you, okay, now your Mlx deployment is ready, and you can find it on localhost 80. I'm gonna try to do that. I'm using PyCharm for development here, and as you can see, I did, I cloned the repository already. I brought up the README here, and I've run through the quick start earlier. I want to make sure I'm on the main branch. Let's add some space. I would do a git pull to make sure I get the latest code. There's been a change. And then I would do a Docker Compose pull to get the latest images that my Docker Compose application requires. And the images that we need are MinIO, MySQL, which we're using as our relational database, MinIO for S3 storage. That's where we store our YAML files and assets that we create. And, of course, we have an image that we need for the Mlx UI and the Mlx API. And hopefully that process of Docker pulling the images won't take too long for you. First time will take longer. Once you have, the images locally, that should go fairly quick. I thought I pulled those just before, but it seems like the Mlx UI image has been updated overnight. So in our little detour here on our GitHub repo, if you wanted to start contributing, you can find, issues that, open issues, bugs, and feature requests that are currently open. And if you want to work on something, you would create a pull request. And then whenever a pull request gets merged, our continuous integration will push a new image to Docker Hub. And then when that happens, and you run your Docker Compose application, it will pull a new image. I apologize, I wasn't aware we had a new UI image that got created overnight. I'm not quite sure how to speed that up here. Once it is ready, I'm gonna shortcut this. You would see the catalog or the Mlx UI similar to our read-only deployment you can find on the mlxchange.org. It should look identical to this, where you can browse our asset catalog, and for each assets you would see the description, the YAML file. You can see the sample pipeline code we generate. However, in the Docker Compose environment, you cannot run the pipeline because, unfortunately, kubeflow pipelines is not part of the Docker Compose setup. For that, we have an open issue that if you want to work on, you can do that, because we want to be able to run Mlx with Kubernetes and Docker. And so we have a long-standing open issue that says we need to create a kind deployment for Mlx that includes KFB. And once that is done, then you would be able to spin it up on your local machine and not just see the metadata and the sample serving code here, but you would be able to launch it just like you would be able to do that on a Kubernetes cluster. And I'm going to go back and see if my Docker image has been pulled. No, I apologize. I wonder if I break this and just do a Docker Compose up, if the previously pulled images will work. They do. Okay. So this one will run with a slightly older image. That should be just fine. That will also take its time. Let me see, in my development environment, I can see the individual containers that are part of my Docker Compose application. And yeah, I can see that MySQL has been started up. Not quite ready yet. I do see that MinIO is ready. And then I will be, when everything is looking nice and blue here, it should be ready. It's still waiting. Let me go back to my terminal. Okay, so the Mlx UI is not ready. At this point, Sri, I apologize. This took longer than I thought it would. We can go back to question answering, and I hope by the time we're done, this will be up and I can show it. Otherwise, I think this was the last thing I wanted to share. And in our slide deck.
Cool. So I think there are a couple of questions which, Tommy, you've already been answering some of them, I presume, so that's good. I think there was a question about whether Docker deprecation impacts this project.
Yeah, so for that, I think I asked in the chat. So in our slide, we showed the Docker runtime because in this demo, we are running on a Docker desktop. So I just want to give some context on what you could get, like what kind of Kubernetes setting you get from a Docker desk setup. But of course, you could use any container runtime in this case. So when you, let's say, run on other cloud provider, a lot of them right now, I think, starting you to use the container D. And that's totally fine with our project. Like we don't have any dependency on the container runtime from like Kubernetes.
Okay, cool. And I know this project is very new. Are there, any customers or any internal use cases wherein this particular architecture has been adopted? And any thoughts on the roadmap on how this is going to go from here?
Yeah, so one of the integrations that we're working on is with the Elira project. And if you're not familiar, the Elira project is basically like it's running pipelines with Jupyter notebooks and more. So we are reusing the Elira notebook runner in Mlx, and conversely, Elira needs a catalog or wants to integrate with the Mlx catalog to use individual pipeline components that can then be dragged onto the canvas and run via Elira. So there's one integration that hopefully we're going to be able to implement in the near future. Tommy, are you aware of further integrations?
I mean, like, I would say we're also working with integration with the CodeNet. So we actually try to import a larger set of catalogs. So when users actually to initialize Mlx, they have a more just catalog to work with instead of like researching their own catalog and try to like upload on Machine Learning Exchange. That's another thing we're like working on at the moment.
Okay. Cool.
Okay, so just to conclude my little workshop demo here, sorry it took longer. Docker Compose finally finished pulling all the images and running the containers. And so once the Docker Compose app has reached a point where it shows you can open the Mlx Dashboard on localhost, you can follow the link and open it in your browser. And then on localhost, you will find the Mlx UI being served on port 80. And then you should be able to see all of the individual assets in a, not just read-only fashion, but you could also upload and register new assets here. And, that could be useful if, team member of yours or data scientist, wants to make sure that the asset they just added, has all the metadata, that the README renders properly, and if there are related assets that, you can follow those links. So this wouldn't be good enough to run anything, but it could help with the development, at least of the asset and the catalog part.
Perfect. Perfect. Thank you so much. And it's 1:10. We went a little bit over time, but this was a very fascinating discussion on, some of the emerging methods of how to kind of take models and pipelines and all the components which goes into the model life cycle and kind of build out infrastructure so that you can monitor and also kind of manage all the different assets you're going to be putting together as a part of your machine learning workflow. So thanks again, Christian and Tommy. And for people who are listening in, this was the final session of the Quant University Summer School. So next week, we have Rob May, who's going to be talking about AI investing. And we're going to be starting the fall school, and we'll be launching the various sessions we're going to be having over the fall, and also the various courses we're going to be offering. So stay tuned for those announcements in the next few days, and we will see you again in another week. Thanks again, Christian, and thanks again, Tommy.
Thank you, Sri.
Thank you very much.
Thank you. Bye-bye.